Hello, this is Garrett Keane, continuing with the series of programs on loops, VBA programs on loops. The one I'm going to look at here is the Maclaurin series to calculate the exponential of x. You'll see over here it's loop examples set 3, and there's a value of x which you have to input and the value of n, which is number of terms which have to be input. So the user inputs these in these text boxes, and then we have to add the code that will basically calculate each term of the Maclaurin series as given in the handout, and also the sum of the term. Each time you calculate a new term, you add it to the running total. We want to display all of these down here for each term a new one is calculated, so it will show us how long it actually takes for the series to converge. Okay, I'll start to write the code now. So calculate yx, and the one thing I'm going to put in, we always have to do it, but we don't have to do, but it's good practice, is to put in option explicit, and that will force you at the top, that will force you to declare all your variables. So the variables we need are dimension, k as an integer, that's going to be the loop variable, n as an integer, that's the number of terms of the series that are going to be calculated. It's up to the user to input that, but there is an upper limit on how big that value can be, because we're working at the factorial, which tend to be very large numbers. Also x, that's the number that you're actually going to get the exponential of, so we need that as a double. Term is a double, that's going to be each term that you calculate, and exponential x as a double, that's going to hold the final answer, but each time you calculate a new term you're going to add it onto that variable. And we're going to need to set up a string, an output string, as a variable called output string, and that's going to be a string type, and that's where we're going to output each new term as we calculate it. Okay, the next thing we have to do is input, so I'll put in a comment with the quotation mark and it goes green, input of x and n, and we say x is equal to the val text n text x dot text. So that will read in, the user will put a value into the text box for the x value, and this statement will read it into the variable called x. A lot of times you don't need to use this val function, but then other times you see that certain PCs it won't work without it. What this does is when you type a number into a text box, it actually reads it in as a series of characters. Say the number 12 would read in as 1, 2. You have to convert that into a number before you can store it into the variable x. Sometimes the VBA will do it automatically, other times it won't, then your program won't work, so that's why I just put it in. Text n3.text. So I'm also reading in n, which the user's input. Then what we need to do is initialize the value of the running total, and we'll set it for the first term, exponential x is equal to 1. This is for term 0. For term where k is equal to 0. So that's the comment, and I'll actually do it with the statement here, and then we can start to write. Now also, when you're putting comments in, I'm going to cut this comment out of here, so cut it, and if you want you can actually put a comment in to the right of a statement like that as well, and sometimes that can be neater to do it that way. So we've initialized our running total exponential x, which will hold the final result, and then we're going to go into the loop. For x is equal to 1 to n, and then remember your tab in, so you can just tab go in 2 spaces, and I'll put in the formula to calculate a single term. X to the power of k, small k, and we declare that where we divided by, and we can use the worksheet function, which is fact, and fact will calculate the factorial, and that will calculate the factorial of k. So if you remember that the term for the Maclaurin series for exponential of x, the general term is x to the power of k divided by k factorial. So that's what we're calculating here. So when we calculate it, then what we have to do is we add it to the running total. So when you have a running total, you say exponential x is equal to exponential x plus the new term that you've just calculated. Then what we have to do is output it to the string that's going to be output onto the text box. So, and I just say here, if term is greater than 1, then output string. I'll explain the reason for this in a minute. Output string, it's basically to tidy up the output. So ampersand k, ampersand VB tab, ampersand format, term. Now there's quite a lot in this, but what we're going to do is output that term with scientific format. And then I have 5 spaces. Now it seems a bit confusing now, but when we actually do it, you'll see that it actually makes sense. So it's format, and now we put out the exponential of x, which is the running total. And here I'm going to use a different format, which is 1, 2, 3, 4, 5, 6, 7, 8, I think it is. Now I've done this with trial and error to basically get this to output nice and neatly on the text box. So that's what all these statements are for, and you'll see them in practice when I actually go to run it. Else, I come down here, now I can copy this whole statement here. So we're saying if the term is greater than the first term, and as I say, this is from trial and error when I ran it myself a couple of times, and really the purpose of it is just to make sure the output is formatted correctly. But in this case, the only difference here is I need an extra space. And I'm putting all this in because when I ran it before, it wasn't lining up properly. Then I close off the loop here, next k like so. And then the last thing, the only thing that's left to do is to output to the text box, which I've called text Maclaurin series. If I hit full stop, yes, it comes up, so I know it's correct. Text is equal to output string, like so. Okay, so there's quite a lot of detail in here, but you'll see that it was necessary to make sure that the output was nice and neat. So if I run through this, I'll go through with the F8 button like we've done before, F8, and I'll get the exponential of 2, say, and we'll do for 10 terms. So if I click in here, I basically press F8, it skips these declarations where we dimension the variables, and it comes in and it reads x. So you can see here that when I click in here, if I come down here and I say in the immediate window and I print x, you can see it's read in the value 2 correctly. And if I press F8, and I'll comment that, just add n onto that, and print x and n, so x is 2, n is 10. F8, and if I print exponential x, do it again, you can see x is 2, n is 10, exponential x is 1. So it's working alright for the moment, so I'll put in term here, and at the moment term is equal to 0, but we've now entered the loop. So in fact I'll clean this out here, and I'll start putting some new terms in here. I'll put in k, term, and exponential x, like so. Now at the moment k is 0, term is 0, and we've already set exponential to 1. So if I now step through here, first line now, k has taken the value 1. I calculate the term, so it's 2 to the power of 1 divided by the factorial of 1. Then what we have here is we take the term, which if I press down here, k has the value 1, term has the value 2, and exponential k is still 1. But if I execute this line, it will take the value of term, it'll add it to the current value of exponential x, 2 plus 1 will give us 3, and it will assign that result back into exponential x. So if I press F8 again, and now I print it out again, you can see that exponential x now has the value 3. Okay, so if I keep going, if term is greater than 1, output string is equal to output string plus k, so we'll print out k with a tab to space it out. Then we're going to print out the term value with scientific format. Then we're going to have 5 spaces, and we're going to print out the value of the exponential, and at the end we have VB new line, which will force the cursor down onto the next line. So each term and its the running total will be output, and each value of k term and the running total will be output onto a fresh line. I skip down to the end if, because term is not greater than 1 yet. Oh, term is greater than 1 in that case, so that's fine. And I keep going. So term now is equal to x to the power of k. So k now has the value 2 if I press here. You can see k is the first value here, has 2. Term is still the previous value, exponential k is still the previous value. So I'll execute this statement, get term, get exponential x. Term is still greater than 1, so it skips down here and it prints this out with 5 spaces here. And I keep running through that, so if I press enter here, you can see k was 3, term was still 2, but the running total is now 5. I run it again, and now k is 4, the term is what is it, 2 to the power of 4 divided by the factorial of 4, giving you 1.33. That's added on to the previous value of exponential x, so we have 5 plus 1.33, and that gives us 6.33. So I'll just press F5 to finish it off. I won't run through all 10 of them. I'll press F5 to finish it off, and you can see here that it's output the value successfully onto the text box. Now the only thing I'd say here, you can see the terms are getting slower. They're in smaller each time, and you can see they're getting in scientific notation. So it started off with the first term equal to 2, but by the time you get to the 10th term, it's 2.82 by 10 to the minus 4. So it's 0.000282. Now the only thing about this is, if you look at this value, it's 7.38899,471, and this one is 7.38871,252. So that's only accurate up to 3-4 significant figures, and really you need more accuracy than that. So what I'll do here is I'll change this to 20. Now I can't, because we're dividing by the factorial of n of k, you know, it'll be the last term will be 20 factorial. We can't really go beyond 20 terms here. But if I calculate this and we run all 20 terms, you can see here that by, what is it, 15, row 15, it's converged to 7.389,05610, and the next value in row 16 has the same value. So you can say that this value has converged to an accuracy of, how many is that, 10 to the minus 8 after 16 terms of the loop, of the series. Okay, thank you very much for listening. That's about it. So you can give that a go yourselves. Okay, thank you. Bye-bye.